Hello guys, good day! I am Joem Gutierrez. In this video, we will discuss about the different measures of relationship in statistics. We will identify the steps in hypothesis testing, differentiate null hypothesis from alternative hypothesis, and give two examples for null hypothesis and alternative hypothesis. So, what is measures of relationship? Measures of relationship are statistical measures which shows a relationship between two or more variables or two or more sets of data. For example, generally there is a high relationship or correlation between parents' education and academic achievement. On the other hand, there is generally no relationship or correlation between person's height and academic achievement. The major statistical measures of relationship is the correlation coefficient. So what is correlational coefficient? Correlational coefficient is the relationship between two or more variables or sets of data. It is expressed in the form of a coefficient with positive 1 indicating a perfect positive correlation, or negative 1 indicating a perfect inverse correlation, or 0 indicating a complete lack of relationship. Next, linear regression. Linear regression is the use of correlation coefficients to plot a line illustrating the linear relationship of two variables x and y. It is based on the slope of the line, which is represented by the formula y is equal to a plus bx, where y is equal to dependent variable, x is the independent variable, b is slope of the line, a constant of y-intercept. Next, multiple regression is the same as regression except that it attempts to predict y from two or more independent x variables. The formula for multiple regression is an extension of the linear regression formula. Y is equal to a plus b1 x1 plus b2 x2 and so on. Next, discriminant analysis. Discriminant analysis is analogous to multiple regression except that the criterion variable consists of two categories rather than a continuous range of values. Next, factor analysis. Factor analysis is often used when a large number of correlations have been explored in a given study. It is a means of grouping into clusters or factors certain variables that are moderately to highly correlated with each other. Now, let us proceed with hypothesis testing. Hypothesis testing is generally used when you are comparing two or more groups. For example, you might implement protocols for performing intubation of pediatric patient in the pre-hospital setting. To evaluate whether these protocols were successful in improving intubation rates, you could measure the intubation rate over time in one group randomly assigned to training in the new protocols, and compare this to the intubation rate over time in another control group that did not receive training in the new protocols. When you are evaluating a hypothesis, you need to account for both the variability in the same and how large your sample is. Based on this information, you'd like to make an assessment of whether any differences you see are meaningful, or if they likely just due to change. This is formally done through a process called hypothesis testing. There are 5 steps in hypothesis testing. Number 1 is specify the null hypothesis. Number 2 is specify the alternative hypothesis. Number 3, set the significance level. Number 4, calculate the test statistics and corresponding p-value. And number 5, drawing a conclusion. Now, what is the difference between null hypothesis from alternative hypothesis? The null hypothesis is a statement of no effect, relationship, or difference between two or more groups or factors. In research study, a researcher is usually interested in disproving the null hypothesis. For example, there is no difference in intubation rates across ages 0 to 5 years. The intervention and control groups have the same survival rate, or the intervention does not improve survival rate. While alternative hypothesis is a statement that there is an effect or difference. This is usually the hypothesis the researcher is interested in proving. The alternative hypothesis can be one-sided, only provides one direction, example lower, or two-sided. We often use two-sided tests even when our true hypothesis is one-sided because it requires more evidence against the null hypothesis to accept the alternative hypothesis. For examples, the intubation success rate differs with the age of the patient being treated, so it is two-sided. The time to resuscitation from cardiac arrest is lower for the intervention group than for the control, so it is one-sided. So that's all. Thank you for watching and listening.